Hey y'all, welcome back. Good to see you again. Thanks for joining the channel. And yeah, this is part 2 of the 75 plus, the Harman Kardon 75 plus. So when I left off last week, I had done full recaps on all the systems. All the circuits got full recap. Pretty much basically that consumed all of my time. I did some repairs to the number 4 amplifier, replaced some dodgy transistors that were substituted in from the previous repair tech, and hopefully our choice is a lot better than his. I'm sure it is. Did a recap the tuner, haven't touched any adjustments yet, and power supply's been recapped. We still need to repair the joystick. I haven't got to that yet, and we still need to do relamping. I haven't done any switch cleaning or anything, but I don't think it needs much in the way of switch cleaning. All the controls sound clean and they're functioning the way they intend. With the exception of the volume controls, maybe a little scratchy. I'll touch that one up. But everything else looks good. So let's get on with the bias adjustments for all these 4 amplifiers. Now, if you go into the service manual, power amp unit, alignment of idle current of output transistors. So you need a high sensitivity DC voltmeter, which any modern digital voltmeter will do. So you're measuring across the emitter of Q347 and the collector of 348, which puts that across. You're putting your voltmeter across both emitter resistors. Remember, the emitter resistors are tied together in the middle, and then there's you put your probes across the 2 outside ones, and they're right up on top here too, so they're easy to access. And just connect them up here on top of the emitter resistors. And the measurement we're going for is 5.5 millivolts, which is not very much current, but it's just enough to turn everything on, turn the transistors on. So let's got it powered up. No, we don't have it powered up. I'm going to turn the power on, turn the volume down. I don't know. I need to get this off of the tuner. There, take that off. Okay, so we powered up, drawing 9.2 watts, and it's dropping. Got 1.2 millivolts. Let's turn this one up a little bit. Now this is cold, so I'm going to have to do it once cold and then wait and do it again when it's warm. Turn it the other way. And we have no bias adjustments. And we've got a problem in that first amplifier. Let's go to the next one. Maybe it was a bad connection. I don't know. Let's try this one. Try this one. It's sort of working. Goes up 23, 24, 26. 5.5 there. Yeah, this pot is sketchy. Let's go back to the first one. That's the problem when you get a 50-year-old receiver. The pots are... And I treated these pots with deoxit too, so they go up so high and then it drops to 0. Let's try this again. Looking for 5.5. Okay. 9.42 watts. Let's try this one. I think what I'm going to end up doing is replacing some of these trim pots. A little bit low. A little bit high. It's very touchy right at the range. Okay, so we got 5.2 there, and we're up to around 9.9 watts now. So start to accumulate some power usage. Let's go to the next one. This one can't reach, it won't reach 5.5. Okay, last one. This one is not making contact at all. I think that pot is dead. Okay, so I got a little more repairs to do. I'm going to change these 4 pots. They're all garbage. Okay, so the potentiometers are set close to where they need to be. When I did it in the last segment there, I adjusted these first 3. This one didn't adjust at all. So they're specified as 5K pots. And if I measure this one, you can see on the machine there. No, that's the wrong side. I'm measuring the wrong side. Okay, this side. If I measure the trim pot now, it's about 400 ohms. If I measure this trim pot, it's about 500 ohms. If I measure this trim pot, 400. And if I measure this one, it is open. So that was damaged. It's no good. So instead of replacing these with 5K trim pots, I have a bunch of 1K. These are 1K 10 turns. And I'll put those in. That'll give us a finer control over our bias settings. And give us a better range of adjustment too. It's not all bunched up at one end of the pot. So I'll put these in, and then we'll get on with the bias adjustment. Alright, a few minutes later I got new pots installed, and let's do this one more time, hopefully for the last time. And we'll connect up our probe wires. Tweaker tool ready. Let's turn it on. Okay, so we're sitting at about 2.5 millivolts. I'm going the wrong way here. I gotta go up this way. .5 milliamps is not a lot of current. It seems it only peaks out at 4.5 volts. Something weird with that circuit, and they're all the same like that. I'm going to try the second amplifier. This one's 4.9 volts. And climbing. Why is it climbing? Climbing faster and faster. Let's turn this down a little bit. Current consumption is climbing, or the power consumption is climbing, and so is that. So that might be something wrong with that amplifier that we don't know about yet. We'll just monitor it. This one's at 4.7, 4.8, and climbing. Let's do the last one. Whoa, that's not correct. It's not getting warm, is it? I'm going to turn this one down. Now the last amplifier has all mishmash of transistors in it. We don't know if the gain in some of those transistors is causing this problem. Probably is. Higher gain transistors creates a higher bias. So we're just going to turn it down. Is that as low as I can go? Oh, keep going. Yeah, well, 1K pot might not be good for this amplifier. Okay, so we're 11, just about 12 watts total idle current. I'm going to let this stabilize for a number of minutes, maybe about half an hour, and then I'll come back and recheck all these and make sure that they're dialed in properly. So what I did is I removed that 1K trim pot and replaced it with a 2K because it didn't have the range of adjustment I needed. And now at that 2K, it goes, I can adjust it down to 5.5 volts, millivolts on all these. They're all balanced, they're all the same now. So I'm just going to leave those alone. And let's move on to this. So as far as I can tell, there's 3 screws here. If we just take these screws out, maybe this whole joystick will come out. Little machine screws with flat heads. Let's take this one out first. And let's try the last one. Okay, so there's my joystick. Screw out. Yeah, it's just a little ball that sits in the socket. Okay, so we got to figure out why. Let me shut this off. So we got to figure out why this broke. When it goes together, it should look like that. So let's see what we can do for this. Alright, now that I got this apart, I can have a good look at it. What I got here is a ball. It's got a hole drilled in it. You can see there is a hole here. And if I look at it with my lens, I can see there was a pot metal sleeve. This part here, you can probably see it on the film there. And this part here, that's broken. The little pot metal sleeve is broken. Now this steel shaft is pushed through the pot metal sleeve, and then on the outside of the sleeve there's this black plastic, looks like black plastic with threads on it. And I think that was to thread this piece into the brass. But it all fits together. But it's not secure. It wouldn't take anything to break that. I don't think it's, this isn't threaded on the inside, so I don't understand why they have the threads. I think the threads are just to hold the black plastic into the brass. But so when I assemble everything and I put it back onto the socket and I try playing with it near there's 2 wires here that this has to coincide with. It protrudes probably maybe 3 millimeters past where those wires are. So what I'm thinking of doing is I could probably shove that steel wire in another 2 millimeters, and that'll fit into that hole. That hole is quite deep. I don't know if there's a bottom to this hole. Yeah, there it is. So it goes in about that much, about 5 millimeters. So let's try this right now. Let's push this down. I don't want to go too far. I think that's about as far as I can go. And that'll fit in there. Oh, that fits a lot tighter. Now my plan is to epoxy this. I don't know if epoxy is going to hold. Epoxy is not the best for gluing metals together. It works great on plastics, but not so great on metals. So I'm going to have to clean this really well, and clean both of these really well. If there's any oil or any residue or anything, epoxy will not stick. So I'm going to clean this up really well, and I'm going to try epoxying it back together again. And if I get enough epoxy on gooped around the outside there, it will squeeze between the ball and the plate, and it'll help hold it together better. It seems pretty rigid now that I moved that. I still need to check and see if this is long enough. If I had a longer shaft, that would be ideal. I could push it in all the way, glue it, and away we go. Okay, I'm going to check this to see how it's going to fit. Okay, I checked the fit, and it fits perfect. This is about 2 millimeters longer than it needs to be, which is perfect because it won't disconnect from the wire, the connection. And it's rigid, it's solid. All I need to do is separate this now, clean it, and I'm going to epoxy it back together again. Hopefully for the last time. That should it should work. I let this epoxy harden overnight, and it looks pretty good. It's pretty solid. I don't know if it's come apart again or not. I don't think it will. I think it's there for the duration now. So let's try assembling this and see how it works. Get this together. So what we got to do is we have to slide it through this ring, and then we have another ring to slide it through. Two of them, and that's our connection. Needs to be working. Alright, now I need to line up some holes here for the screws. I can't really see. Can't really see here. Let me try this. There we go. Right there somewhere. I'll hold that there. And then I need to get this back together. Okay. Now, without that falling apart, I'm going to get the other piece on. If I can get one screw in to hold this together, I'm away at the races. Okay. Two more screws. And last one. Yeah, I got those screws way too tight. And back them all off. And that's how that works. Okay, but I think I'm going to need some lubrication on this. This is way too tight. So let's try giving a little bit of magic grease. Let's actually get it a little better. Don't put too much on because I'll just be wiping it all off again. Need some on this side maybe. That's better. I don't think I need to put any on the washers. I think they'll just slide around. Now, let me see. These screws, if I loosen them really far off, I got a lot of freedom there. That's too much. I'm going to have to lock these screws in place because if I tighten them right down, the thing won't move. So I'm just going to tighten this up until it's good, and then I'm going to lock them down with some, probably what I'll use is probably hot glue or something. Yeah, that's about it right there. Perfect. Okay, I'll lock those screws and it's fixed. Result. Okay, so now that I got everything back together and everything's the way it should be, the amplifiers are set up, I can now do my power tests, my after power tests, the power consumption tests I should say. So let's turn this thing on. Right now we're at 0. Hope you can see that. Let's turn this on. Climbs up to 45 or so, and then it settles down. And then it climbs back up again. This is with the power amplifiers connected, and they're drawing current. I just want to see how this goes and how far it goes. So let's see. I'll come back when it's ready. Okay, so it looks like it's been on for probably 4 minutes now, and it's plateauing at around 31.3, 31.4 watts. Now that's gone up, so 31.4. I happen to think that's because the amplifiers are now biased properly and they're starting to draw their proper current. So what I'm going to do is I'm going to disconnect the power amplifiers, and then we'll measure the other ones and we'll see what kind of a change we had there too. Alright, I got the power amplifiers disconnected. So let's try this one more time. Let's see what we got here. And I am on Phono right now. And it's still climbing. I don't understand why it's climbing. That's the thing I don't get right now. And now on Phono. It's going to let this settle for a while. Okay, so on Phono I got 14.4, and that has gone up actually. That's surprising. Stereo FM. Stereo FM is 27.6. That's gone up also. Auxiliary. Auxiliary. Now I'm up to 14.45. I'm curious as to why it's gone up. And this is the AM, 24.4. That's also gone up. So our power consumption has gone up by about, across the board, about a watt. I wonder what that's all about. Is that from new capacitors? Are they still forming? I know these capacitors will take, any of these capacitors that I installed, they'll take about 2 weeks to hit their happy spot, their equilibrium. That's unusual. I thought for sure it would have dropped, but it went up. Alright, update time. So I've been working on chassis stuff now. Let's see, I replaced the incandescent bulb, the burned out incandescent bulb, with an LED. It's a red LED, just so that it shines through on the red button. Now what I did is this circuit here ran on 4 volts AC, and then it had an incandescent bulb, so I removed that bulb, and I've had a little diode here. You can see the little diode, and there's a 22 microfarad capacitor that forms my little power supply, and that outputs 5 volts DC. And then I have a dropping resistor here, 330 ohms for the current limiting for the LED, and a red LED. It provides about 10 milliamps of current, and it's plenty bright enough to light the button up, so that's good. Another thing is, this power switch here is really concerning. You can see the wires are right next to the wiring for the headphone output jacks. So my solution is I got a little piece of insulating plastic, and I'm just going to fold it, and I'm going to put that in there as a little shield between the two, a little barrier, and I'm going to silicone it in place so it doesn't fall out. So that's going to help improve safety there. See, we got the line input here. This is the line cord coming in, this one here, that the sheath on it, and then the white wire is the return to the back here. So if I can fit this in, and then I don't have to worry about ever a short in between those two sets of wires. Okay, just like that. And like I said, I'll tack that in with some silicone so it won't fall out. What else did I do? I added a cross the line cap. This is an X-rated 250 nanofarad. It's pretty beefy. One thing I noticed with all these old Harman Kardons is they pick up a lot of line noise, and every old Harman Kardon I've listened to has it. When I'm listening to it, I get snaps and cracks and pops from noise coming in the line cord. And you know, if you have something switching on and off like a refrigerator. I don't notice it on newer equipment, and I think the reason is because they have a better input protection, more interference protection here. So I added across the line cap just to suppress that. I'm going to see if it works or not. I think it'll help a little bit. I don't think it's going to get rid of all of it. I was actually thinking about getting one of these little noise suppressors. This is a little noise suppressor board. This is, I robbed this out of a microwave, a salvaged microwave, and it has line in, neutral and line, and then it goes over across 100 nanofarad cap, common mode choke, and then it has two, I think these are like 4700 picofarad or something like that. I can't read them, and they go to chassis ground, and this one's fused as well. So I salvaged these little boards out of microwaves, like I said. And I was thinking of installing this somewhere in here, but there's really no room down here. There's no room whatsoever. There's room up top, but then I'd have to make brackets and it would look really out of place. So I decided against it. And I just went with the single cap for now. And we'll see how that one goes. And we'll see how that works. All right, let's see if we can get this in shot. So this is why I don't like doing alignments in old tuners. See this little capacitor here? This one here? It's broken. Now, why is it broken? Well, take a look. When I spin it, the solder blob moves, but the disc below it doesn't. It's fixed to the base there, and it's stuck. So when you crank on it, usually what happens is you break the bond between the ceramic disc and the screw. And yeah, so it looks like typically what you can do is, well, of course you can replace this. I don't know what the value is, but then you could try resoldering it. Instead of on where the blob is, try and solder the screw back to the disc on both sides. I might have to remove it to do that. See, what I was doing was I was unsoldering this shield, and like a dumbass I didn't protect the dial cord, so I snapped the dial cord. So we're going to have to record this thing. It's not a big deal because we have full detail instructions in the manual, and it tells you if you follow number 1 is start and you follow the numbers, it should be easy to go. So we're going to do that after, but let's get this capacitor fixed because we can't complete our alignment with that capacitor shot. That is TCO, that is the tuning capacitor for the oscillator, and that is for adjusting the high end of the band. So that's what I was doing. I was going through and tweaking it. Okay, here I got the tuning cap out, but it only wanted to come out in pieces. It didn't want to come out as a unit. But yeah, it's defective. Here's part of the ceramic disc, and here's part of one of the plates, and this it sits on top. And this has a little bit of ceramic plate on it too, and this goes through the hole. And this is supposed to all be one piece. Try and imagine. Use your imagination. So I'll try in one piece, and then when you turn it, that disc was supposed to turn, but it wasn't turning. It was broken. Yes. So I have some options. I don't know what value this is. This one here measured 5 to 25 picofarads. So that's an option. I got another couple ones here. One's painted red, one's painted green. And these are 5 to 30 picofarad, I'm not sure. And then the last one I got here is painted green. This one is 5 to 65 picofarad. So I think this is the one I'm going to go with. Now you see when you turn it, the whole disc is supposed to spin as a unit. And that solder is to bind the screw and the plate together. But usually what happens is flux can get in behind the plate here, the ceramic disc, and it can bind. And then when you try and turn it, you break the bond here between the solder joint and the ceramic. It's just a thin layer, thin plating of silver. And you see it's silver, it's all black. So I'll put this one in, and if I find that the tuning is too sensitive and I'm unable to tune it, I can put one of these smaller range caps in, and we can do that. So I'll go do that now. Alright, so I changed the tuning capacitor, or actually a trimmer capacitor, on the FM tuner, TCO, and now let's clean up this other mess I made, this dial string, because I can't continue with the dial calibration and everything if I don't have a dial string working. So we're very fortunate. We have a diagram here telling us how to string it, and it's pretty simple. You start at number 1, where it says start, and you tie it up to that post, which is right here, and then you just follow the numbers. So you go 2, 3, 4, 5, 6, 7, 8, around 2.5 times 9. Let's see, where's 10, 11? 10, 11, I think you put 2 wraps, and then 12 goes to the spring. So typically on these, if the service manual has a diagram, typically they have a length of what the dial string should be in millimeters or meters or whatever, and you can cut a string beforehand. See here, I don't know what the string length is, so I'm going to take it off and measure it. I got it in 2 pieces now because it's broken, obviously. So I'm going to take it off, measure it, and then I'll know how much string to start with, and I can add a little extra for tying knots on the ends. And we'll do it that way, because it makes it a little easier if you have your string pre-cut. Now this one here, this is called the drum, and the string is glued down to these posts. So I can just pull this string off. Okay, there's one end of it, and the other end has the spring on it, so I'll take that off too. It's got some sticky goop here that's holding it all together. After 50 years it's still sticky, and just got to keep prying at it. It's just, there we go, a little chunk of foam here to keep the spring noise down, and it's all removed. Okay, so there's my spring. A little rusty, but so I'll clean this all off, and then I'll so we can remove this string. And we can measure what our length is. Okay, so we got both strings out. I'll measure them, and then I'll cut a new piece. Alright, so I did some measuring. One piece was 1.26 meters, the other piece was 0.5 meter long, so a total of 1.86 meters. So I'll just take my new cord, and we're going to tie a loop knot in the end. So I do it with extra, I can cut it off. I'm crap at tying knots. I never did learn when I was a kid. Okay, so if I can get this to I just want to tighten up the loop on this. It's a little big. Okay, that's going to have to do. So I got a loop on one end. Okay, so this will be the end of my cord, and then I'll measure at 1.86 meters and cut it. Well, I'll cut it a little long actually. Alright, I got my new dowel cord here with a loop tied on one end, and I cut it to 2 meters just so I have lots of extra room on the other end to tie my knot. I'm just going to cut off this excess for now, because it's just going to be in the way. So what I'm going to do is I'm going to try following the diagram here. I'll put the diagram up on the bottom of the screen here so you guys can follow along. First step is to close your tuning capacitor so the plates are fully meshed, and then we can start stringing. So I remember this post here was the spring, and this post here was the end of it. So we're going to start with that. So I'm just trying to, my diagram is backwards here, so I'm going to try and do this. I'm trying to, let's see here. Okay, so I got to go around here, this way, up to here, over this pulley, under the drum, way is it now? 3 goes under the drum over the top pulley. It goes down to the far end. I need to go under this dial lamp cord though. So I go under here. That goes to the pointer. I can actually engage that on the pointer right now. I don't know if you can see this. Is it out of frame? Yeah, it is, probably. Trying to keep everything in frame here. Down to this bottom pulley and back up again. To this pulley. Okay, now we need to do 2.5 wraps on here. So I'm going to feed it through. Here's my tweezers. Okay. There's 1 wrap. Feed it through again. Two wraps. Okay. I feed it through 1 more time and that'll be my half wrap. If I can find the end. So let's feed this through 1 more time. Okay. Here's my 2.5 wraps. Now it goes around this little pulley. And what we need to do is, how many wraps do we go around here? 10. I think we do 2 wraps. 11. And then here's where I attach my spring. So, is it working? Well, we don't have any tension on it yet. We need more tension. Okay, it's working there now. So we need to get a loop here so we can put our spring. So let's measure. I want my loop to be right. My tweezers again. This is the hard part because you have to figure out where the loop goes. I got my arm in the way. So spring connects here and then it stretches out and it will end up probably right about here. So that's where I'll put the end of my loop. So let's pull this off and then I'll tie my loop. I have to make this one a little more precise than the other one. Be easier if I do this. I can pull it through. There we go. There's a loop. Okay, let's measure it again. Okay, and we're too short. Everything's correct. I might have some slack somewhere. This is too correct. So my loop's probably, ooh, let's say about 6 millimeters too short. We can retie. I'll try retiring it and we'll come back. Okay, so what they do at the factory is they have the spring, it's already glued down to the drum, and it's compressed, it's not extended yet. But what they do is they loop the end of the string through the end of the spring, and they have this little brass ferrule on the end here. And what they do is they pull the end of the string tight to tighten it and tension it, and then when they have the correct tension, they crimp this little brass ferrule. And what that does is it holds it, and then what they do is they tie a knot behind it, and then they goop it with locking paint. So that's how they do it at the factory. It's pretty easy. And I could probably remove this ferrule and use it over again. Instead of trying to tie a knot at the correct spot, I could just use this and adjust it on the fly and seal the deal. Okay, the spring's off. Remove this. That's off. Okay. And yeah, it's just a simple knot to tie it so it doesn't slip. So what I'm going to do is I untied my loop. I don't think it was working because I couldn't get it at the right spot. What I'm going to do is I'm going to try their method. And I got the spring attached here. It's just sitting in place. It's not secured down yet, but I'm going to do this again. So we got 10, 11, and 12. Okay, so I got my little ferrule here. I'm going to feed it through. Let's see here. Feed it through. And we're going to try tensioning it with this method that they use at the factory. So I just need to get it through the spring now. This is the hard part. Okay. Oops, I lost my ferrule. Try that again. Okay, now I need it through the spring. I need 3 hands, that's what I need. Now let's just do this. Take the spring off. Take the spring off and we'll do it here. Okay. Through the spring. And back through the ferrule again. Okay. So now I need to tension everything properly. We're loose here. Why are we loose? Okay, I think I got it all tensioned properly. Let's connect our spring back up to the drum. And I pull on the loose end, and this will provide me with the proper tension. Okay, it's working. I still think I need a little more tension though, so let's pull on it. And get quite a bit of tension. And then I'm just going to crimp this ferrule with a pair of needle nose. And hopefully that'll hold the string in place without cutting it. And it did. Okay, good. No, it's slipping. Okay, let's take this off. Relieve the tension. So what I can do now is I can tie my knot here. And then that'll be it. So let's tie a knot. Some kind of knot. You want to get it nice and close to the ferrule so that it doesn't slip. Okay, there's my knot. Let's cut the excess. Okay. All right. $10, $11, oops, $10, $11, attach the spring to the post. It's got lots of tension. That's good. That's what we want. There. Just going to cycle it through a few times because we had some overlapping cords here. It seems to be working. Okay, now what I'm going to do here is on these two posts they had glue holding the string and the spring down. I'm just going to use hot glue and I'm going to flood the area here, and this will be my new string anchor. I'll get some on this side. I hate hot glue, it's a mess, but it works good. Okay. Don't need too much, just to anchor it. Remove all the excess. Okay. Last step, we need to attach the dial pointer. In the instructions they say set the pointer to the 0 on the log scale. I don't think there is a log scale here. I don't see one. If it is, it's probably hidden by the smoked glass. So, pointer at 0, tuning capacitor fully closed, and then we slide this to the right position and we anchor it with some hot snot or some other glue that will adhere that string and lock that in place, and then we have a fully functioning dial string. One last thing I'm going to do before I finish, I'm going to lock these knots I made with some paint. And that'll just absorb into the string and lock it from unraveling. There. Now what do you do if you don't have a diagram? Well, I suggest the best thing you could do is maybe get photographs from a different unit and see how the string is laid out. Get some string and try different routing scenarios to see how it works. This one's working pretty good now. Just run a few times. Yeah, if you don't have a diagram, if you don't have any clue, best thing is if the string's still in its position, if it's just broken and it's laying there, try and take photos of how it's routed, and maybe draw up a picture like they did here with the thing. Pay attention to which way the wraps come on and off these shafts, how many wraps there are, how many wraps on the drum, which direction they're going. I've had where you've finished stringing the thing up, and then when you turn the dial knob, this is turning opposite of what it should be, so it's backwards. So then you have to take this apart and reverse the direction on this shaft. And but yeah, this is working. I think it probably could have used a little bit more tension. I don't have much tension on there. Yeah, it's pretty slack. I'm just wondering if with time is that gonna go slack and start slipping. I hope not. Okay, there is a 0 here, and it's right between the FM and the 88. There's a little 0. You can see it here. So what do? I'm just gonna slide the dial indicator. Actually, first thing we do is we close the tuning cap completely. Okay, so it's completely closed, and then we slide this down so it matches the 0 right there, and then we anchor it there with some hot glue on the string, just so it doesn't slide away from that point. So I'll do that now. And it would just let that cool, and then we're done. All right, for AM/IF, I have at 455 kilohertz, 30% modulation, and minus 60 dBm signal going into the tuner. It's kind of struggling picking up that, so let's see what we can do here. So our adjustment points is going to be T162, which is this can here, and T161 is double can. So what I'll do is I'll put the camera on the meter, and we'll get through and adjust these. Just going to kill the lights. And I'm just trying to adjust it to a quiet spot on the band here. Okay, start adjusting. And we're looking for maximum centrifugal pattern of scope. So we're looking at the maximum here. And we can peak this one a little bit. Got a little gain out of that one. Let's go to the next one. Well, that one was close. A little peak here. And now the last one. So the IF strip was not far out. I'll go through and do these 3 one more time. Yeah, the AM really didn't need any adjustments. It was pretty good. Okay, next step. So next step, set the signal generator to 525 kilohertz, 30% modulation, minus 60 dBm, whatever signal I can hear on the radio. So that's where that's set. So now for this adjustment, we're going to adjust L162, this red one here. This is the oscillator coil, and this is going to set up the bottom end of this scale for that 525 kilohertz that I tuned the signal generator to. Okay, so I'm pretty much done with everything I need to do here. And the only thing left to do right now is do the power tests. So I want to do 3 power tests. I want to do a power test on the front set of amplifiers, a second one on the rear set of amplifiers, and then I want to do a third power test in bridge mode, just to see what this thing will do. So right now we're doing the front. I got it set up, my dummy load set up on the remote speakers, and I have set up on the on my main speakers, on the mains I have my speakers set up. So here it's coming up and we can hear it. So let's turn this off so you don't hear that noise. And I believe we're all set. Everything's flat. And let's turn it up. Let's see what we get on that. Okay, there's clipping. Let me turn this down a little bit. Yeah, it's better. So the balance control is working. So we have a little bit of clipping on the left channel. Left channel's top. So I'll back that off a bit. That's the channel I'm measuring. And we have 14.0 volts RMS on the output. All these are cold. Why are they cold? Should be warming up. It's barely breaking a sweat here. I don't feel any heat. I'm at full power into 8 ohms and I'm getting nothing. Is this really slow at warming up? That one's cold. That one's barely warm. Okay, so this one's warming up a little. This one's warming up. These two are stone cold. And just going to let it go for a while. Okay, so this has been on full power for more than 5 minutes now, and my my dummy load's getting quite hot. This amplifier here is barely warmer than room temperature. This one's stone cold. Barely warmer than room temperature and stone cold. So this is a fairly efficient amplifiers. They're not even breaking a sweat and they're running at full power. So there's probably some good ratings on those output devices and the heat sinking itself. Even though those heat sinks aren't very big, they're barely getting warm. It's unbelievable. I've never seen a amplifier do that. Usually they stay around the same temperature as my load, but this is incredible. Okay, so yeah, it's proved its point. 5 minutes or more. It's been 6 minutes now. Let's shut this down and let's switch over to the rear amplifiers. Got it switched around to the back rear amplifiers. Let's turn this up. And we got an issue already. I can see a problem with one of these amplifiers. The right channel is blue, yes. Okay, so we got more repairing to do. Got a dead transistor here. What's going on? Okay, left channel's working great, right channel's all butched up. Let's confirm this right channel. It's going to take a ground signal here from somewhere. Okay. So this amplifier still got issues. Now, I'm guessing I never did check the output devices. That's probably the reason why it's doing this, because I missed something. So let's shut this off. Let's pull this amplifier out and let's sort this mess out once and for all. Yeah, I have a feeling maybe one of these output devices are gone. That's funny because it biased up fine. Okay, so this amplifier is giving me grief here. I wonder what's going on. Replace these 3 transistors. Let's test those ones first. I know I tested them before I put them in, so they were good. So what do we have here? We have, it's marked on the board, but the board is so burnt. Emitter, base, collector. Okay, so the base is here. Emitter, collector. Switch these around. Emitter. That looks normal. Same thing here. Emitter, base, collector. This is a PNP. That looks good. That looks good. This is low here. It says 485. So that's suspect. Maybe it's this transistor. Base, emitter, collector. Base is in the middle. Yeah, look at that. Okay, that's probably the reason. We've got base emitter leakage. Let me see that again. Base emitter leakage. Let's pull this one out. Okay, I'll clean up the board. This is to a C853. And I have a feeling it's bad, so let's check it. Okay, here's my little tester. Alright, here we go. Test's fine. Hang on. Let me clean this. Why is this so dirty? What is on there? NPN, gain of 61. Base collector emitter. Base collector emitter. One base, two's a collector. Well, this test's fine out of circuit, so let's go keep looking. Let's keep looking here. Actually, let's test these 2 big ones. Which is the collectors are red, base is a green, and the emitter is blue. Base is green. That's not good. Okay, let's try that again. That's not good. That's normal. Let's try this one. We got a difference between the two. I think we might have a leak on one of these. Let's pull these two out and test them. Okay, let's see what we got here now. That one tests fine. That one tests fine too. What is going on here? Emitter collector base. Let's check this one. Everything's good. So all that's left to check is the long tail pair, and we have a pair of A6 2SA 640s. Okay, let's try these. I don't think this is a problem though. Oh boy. Let's try the two emitter resistors. Maybe one's burned out. No. We might have a shorted diode or an open resistor, that's what I'm guessing. .3, this one's 100 ohms. Ten ohms. 100 ohms. 3.9K. 5.6K, 180 ohms, 27 ohms. This one here, I don't know what this is. Probably 0. 180 ohms. 390 ohms. 33K. 3.3K. 33K. It's taking its sweet time. 2.7K. 6.8K. They're all within tolerance. Another diode. And that's it. Everything checks out. I'm going to check these two out of circuit. Maybe we had a bad connection on one of these pins. That's possible. Everything else checks out fine. Even the driver transistors are behaving well. Let's try this again. One of them could be bad, I guess. They both check out fine. So if we're missing half a signal, it has to be either this transistor is not conducting or this driver transistor is not turning this one on. The long tail pair, and then this is the feedback. This one's biasing. Both of these are biasing, I think. And then the signal goes through. You might have a break in the signal path here somewhere. But it was the negative going portion of the signal was missing. So that's the lower part of the schematic here. So there's a signal missing here somewhere. Or we were missing a power supply rail, B2. I don't think so. Okay, let me check these two transistors again. I'm suspect of these. Okay, I've been testing this thing. I can't find anything wrong with it. I can't find anything wrong with any of the transistors. Now, there's lots of broken pads or lifted pads on this board from people working on it in the past, and myself included, because you know, it's just a very poor bond between the copper foil and the board. But as far as I can tell, they're all connected, and there's no broken traces anywhere that I can see. I removed this transistor and tested it. It tested fine, but it had one short leg. It was way shorter than the other two legs. So maybe this one had a broken leg, and I didn't notice it until after. Maybe I didn't notice it when I pulled it out. It could have been sheared off at the board. Everything else tests fine. These two transistors tested fine. Another possibility is the grease got on the pin here and was insulating the contacts from conducting. So I'll reassemble that. Really not much more to do here other than hope it works. Alright, so I pulled that amplifier out and I looked at it. I couldn't find anything wrong with it, and with good reason too, because there's nothing wrong with it. I was just checking signals going in and out. So okay, here's the amplifier that was suspect. This is the output. You can see it on the screen. And that don't look right. If I check, let's see, the other channel. Let me turn the balance control. You can see it's nice sine wave, but on the bad channel, it's low and it's distorted. Okay, now let me check the input here. Ah, look at that, it's low and distorted. So it goes to this stereo 4-channel switch, and then it goes back to the inverter board, I think. This inverter board should have both signals on it. Should have the good side. Let's try this. Well, that's silent. Is that the other side? Where is this? It's up here somewhere. Okay, so is this it? I'm getting no signal here. Well, the inverter board shouldn't be in play because it's switched to 4-channel mode. Switch it to 2-channel mode and we get nothing. Okay. So where is that signal coming from? It's specific to that one amplifier, so it has to be within this chain between, let me see here if I can show you. The one amplifier, let's say it's this one, I'm not sure, 100% sure. But if it's this amplifier, if I feed back, it goes through the 4-channel switch. Into the low cut switch. And from there it goes into the high cut switch. And from there it goes into the preamplifier. So we might have a problem with one of the low cut or the high cut switches. Let's check this. I don't think anything's wrong with any of those switches. And then previous to that, low cut, high cut, we have the 4-tone amplifiers. So let's go and check these 4-tone amplifiers, make sure that we have we're getting a distorted signal out of one of these. So let's check this board over. I got yellow, orange, gray, and brown. Okay. So I don't know if you noticed, but these are all color coded. This channel's gray, this one's orange, this one's brown, this one's yellow. So we're having a problem in the yellow channel. So if I can go back, I can trace wires back. All these yellow wires are going to coincide with my signal path. Kind of makes it easy for me. So there's, for example, there's one right here. Let's check this signal. It's distorted. That's an output signal, I believe. Let's yank that card and have a good look at it. Okay, so we checked the power amplifier and we know the signal's coming in distorted. And then we looked back through these 4-channel, 2-channel switch, stereo 2-channel, and since the signal's not going through the inverter board at that point, we could ignore that, and the signal is coming from actually the high cut board and low cut board. There's a little printed circuit board with switch on it, and it's got resistors, capacitors, low, high pass networks, and the signal's going through here no problem. And I measure on one of the outputs of these preamplifiers, and we had distortion. I'm not sure which one. I think it's this one here, the bottom set. So we got 3 transistors and a couple capacitors, and that's the circuit here. This circuit here has got 3 transistors, output capacitor, input capacitor, and a stage blocking capacitor. And I looked at this board, and I cannot find, I looked at it under magnification, I can't find any bridges, and I can't find any cracked solder joints, can't find any open solder joints or broken traces, anything like that. The board looks good, and I checked this over on this top side. I don't see anything going on. Everything looks good. I tested all these, those are 12 transistors here, and they all seem normal. Didn't have any cause for concern, unless we have an open resistor somewhere. So this negative leg of the capacitor is our output signal, and that's right here, C615, 100 microfarad, the negative, that's the output. And the negative of C611 is our input. So C611 is right here, negative is right on this side, right here on this side. So I can test for a signal here, and I can test for a signal here and see if they're distorted. If this is clean and this is distorted, we know the problem's somewhere in here, or it's on the tone control board that has the potentiometers and the resistor capacitor networks. Well, we're running out of things to check, because right here actually is the input for the amplifier. This is where I'm feeding the signal in. So of course this is going to show clean unless there's a problem with the switch. So let's test here. We already tested here, got distortion. So we need to test here, and then we need to go back a stage and test here and here and here to see where that fault lies. Okay, here's a little look at what I'm looking at here. Let's turn it on. Okay, our right channel, oh sorry, left channel is working fine. Still a little scratchy though. Right channel though, we're having problems, and I'm talking about the rear amplifiers, not the front amplifiers. So if I put it on the right channel with the joystick, you see you got distortion when we turn it up. Now have a look on the scope here. I'm going to start checking these 4 capacitors. Here's one. That one's got no signal. That's a front amplifier. Let's see. Let's put this in the middle. Yeah, that one's got nothing. This one has our signal. This is the left channel of the rear, and then the other channel of the front, and then this is the right channel of the rear, showing nothing. But when I jack up the volume, see we got our distortion there, and that's in the output of the line amplifier that sends the signal to the power amplifier. Here's another thing I noticed. So I'm going to check the output of each amplifier, and I'm checking between the collector of the transistor and the blocking capacitor, DC blocking capacitor. So here's one channel, 10.2 volts, 10.3. This is the left channel of the rear amplifier. It's 11.38. It's a volt higher. I don't understand why it's a volt higher. It's odd that it's a little bit high. The other channel of the front amplifier, 10.15. Here's the defective channel, 2.6 volts. So I don't know if that transistor is defective or it's not biased properly. It does not have the correct voltage on the output there. Now I'm checking the input voltages here, and I'm getting let's see here, here's one I'm checking, 15 volts. Here's the other one on a defective channel. 14.5 volts. Maybe it's drawing more current. Beginning to think I might have a defective transistor in this channel, or we got all brand new capacitors. That could be a possibility. We got a bad capacitor in there. It's a long shot though. Or we have bad resistors. And I'll pull this card out and I'll have a good look at it and scrutinize it and see what's going on with this channel. Okay, so I think I'm making a little progress here. Let me pull this board out first. So this board here, I yanked these 3 transistors and tested them just to make sure I didn't miss anything. They all test fine. Capacitors test fine. All the resistors test fine. I don't believe the fault lies on this board. What happens here is there's an input on this trace, and it goes into this little first amplifier, and then it goes out of this amplifier on these 2 traces on the outside here, and it goes to the tone network. There's a tone board here that has resistors, capacitors, and this sets up your bass treble, and then it returns on these 2 traces. That's what it is. And these 2 traces go to these 2 transistors, and I think what they do is they provide some amplification and provide the line out signal for the power amplifier. Okay, so on one of these, well, let's check these three here, because these 3 on the outside are signal lines. 1 going out to the tone board, 2 returning from the tone board. So let's plug this back in, power it up, and we'll see what we got on those lines. And that should tell us where the fault lies, if it's on that board or if it's somewhere else. Okay, so let's hook up a ground. And you got your scope on the screen. Okay, so let's turn this up. So this first one here would be going out to the tone controls. You can see I got a normal signal here. Okay, now this is what's coming back on one line. It doesn't like that. Let me try this again. Turn up the signal. Yeah, we got distortion on that one. And distortion on that one. So distortion on both of them that are returning. So there's our problem here. I don't see anything. You might have a leaky capacitor. So next step, I'll pull out these tone controls and we'll have this good look at this board, see what's going on here. There's something wrong with either the wiring. The wiring seems fine though. Or, yeah, there's got to be something going on with this tone board. Alright, so that's, I'm going to take it all apart again. Okay, have a look at this. I've been racking my brain here on this thing. I pulled the tone controls out. Everything looks good. I don't see anything wrong with them. I tested components, they're fine. I don't think that's the problem. I think the problem still lies in the amplifier here. And I'm getting funny kind of results. So when I turn it on, it starts with the distortion. I'll show you here. Turn this up. And as it warms up, it gets louder. You see it getting louder on its own. Turn down the volume. keeps growing in amplitude. And I happen to think it's because either I got a resistor that's gone thermal, or there's a bad transistor here. So let me spray a little bit of cold on it, the transistor. That's the first one. Doesn't seem to have much effect. Let's spray the second one. Oh, look at that, it disappeared. That second transistor is suspect. Warm it up with my finger. Warm it up with an iron. Yeah. That transistor's buggered. Okay, now I know what the problem is. I'll pull this out and I'll show you. So it's this middle transistor here is not behaving. I'm going to pull it out and replace it. Now I don't know if I should replace. Yeah, I'll just replace that one transistor and I'll be done with it. And looks like that was the problem. Alright, so this one here is suspect. And that is Q612. And if we look at the schematic, Q612 is right here. And it comes after the tone controls. There's a 1 microfarad blocking capacitor, DC blocking capacitor, and then it's like a high gain amplifier. And before it goes out to the high cut, low cut, and then it goes to the power amplifiers. So what I'm going to do is I'm going to remove this one. I pulled it out before and tested it, and it tested fine. But you know, DC checks and all that is not really. Let me see here. Yeah, just the DC tests aren't going to tell you everything. Let's just pull this one out. Let's see if we can. Okay. The Harman Kardon manual specifies a what is it, 2N3417 or something like that, which is probably today is probably not available. So this is the one. Let's test it again, because this is the thing that fooled me. But then it doesn't test everything. So let's see what we got here. Oh, now it's not going to test as a transistor. It's going to test as a diode. Let's see this again. Okay, here it goes. You can see that. So it's testing as an NPN bipolar, a gain of 329. And we got emitter, collector, base. Emitter, collector, base as our pin out. Emitter, collector, base. So I'm planning on using one of these KSC 1845s. Let's see what this says. So we have NPN, gain of 370. Same thing, emitter, collector, base. So it's just direct drop in. Let's put it in and try it out. I'm kind of wondering if I should just replace all the transistors on this board. If they're going to be problematic, I can just change them out. We'll see if this is the fix. Clean this up too while we're here. Okay. Alright, let's plug it in and try it. Hopefully that's the cure. Okay, so here we are, power on, turn up the amplifier. Left channel. Right channel. A little bit of a buzz in my right speaker, I can hear it. But I think the signal is clean because I'm going to check here. Here's the left channel. That's what's coming out of the preamplifier. That was the good channel, and here's the right channel, the one that was bad. It's now all cleaned up. So let's do a power test and we'll see how this sounds under full power. Okay, let's get this thing going here. Let's do our power test before something else blows up. We are on. Just as a reminder, we're testing the rear amplifiers, left and right. So we got them both in signal there. Okay, let's shut out speakers off. Let's turn this up. You're getting a nice clean signal this time, not distorted like before. How come my probes are times 10? Let me set this properly. Okay, take it up to clipping. Right. Well, let's say right there. And what do we got? Actually, I got a little too high into clipping. Let's take that back a bit. Right there. And I got 14.25 volts AC on the output. Let this go for 5 minutes like the other amplifiers, and we'll see how they warm up. That transistor that was bad, I suspect that was there from the beginning, but when I did my listening tests, I don't know if I heard that noise or not. I don't remember hearing a distortion in that right channel. That's odd because there's really nothing I did to that board that would cause that transistor to fail. I replaced the caps beside it, and maybe it was just on the verge of failing, and the little bit of work I poked at it maybe put it over the edge. I don't know, but that's unusual, that failure. That's why it surprised me, because when I initially tested this receiver, it sounded great, and then I tested the back amplifiers as well, and it sounded great. It had a really clean sound. So I don't know why all of a sudden when I do the test the distortion's there. Okay, it's been going for about 6-7 minutes now, and this is quite hot. And again, this one's cold. This one's slightly above room temperature, ice cold, and barely warm. I can barely feel any heat here. So it's kind of the same thing as before. Well, it is the same thing as before. Alright, so let's shut this off. Let's reconfigure this for bridge mode, and let's try one more time, see what how this thing kicks out. Alright, so I got the amplifier configured for bridge mode, so let's turn this on, and I believe I have the correct inputs. Let's turn up the volume, and there's our signal. It's going to keep going up. And I ran out of headroom, so I got to give it more signal. Hang on. Let's double this. Okay, here we go again. Keep going. Ooh, get some ugly distortion there. Okay, hang on. Let's get a better look at this. Okay, let's go again. Yeah, we're getting a distortion right at this point. I wonder what that noise is. So at this point we are at 9.9 watts, or 9.9 volts RMS, and we're not doing too good. Maybe we have another problem here. Oh, and those two are getting hot. Okay, let's disconnect this ground. There we got full clipping now. Now we're getting 22.69 volts RMS max. And that's a little more comfortable. That ground wire was shorting everything. So everything appears good, it's functioning normally. I'm going to wrap this one up. Let me finish a few details, secure the cards down, wrap some wires, tie some wires up, do a little bit of more cleaning, and then we'll finish this off. Well, there you have it. I wanted to get this finished and done so that I could post it for the Friday. What is today? Friday the 29th? July? I think it is the 29th. I wanted to get this posted for the 29th, but it just ain't going to happen because of the F up with the dial cord string. I had to restring it and then hunt down that distortion that appeared out of nowhere. So that threw me back on my schedule. So you have to wait a week. You have to wait another week to see this episode. But this one's done. I'm going to put this one to bed. There's a lot of work that went into it. Like I said, the caps were, I did a full recap on it. 4 transistors, one of them defective, burned out lamp, 4 defective trim pots, and these main filter caps. Now I had a comment on my last video on this amp, or this receiver, about these Nichicon They're 6800 at 35 volts. Now, what I did is I connected them up to my meter, and it showed a DC resistance of 50 some ohms. That was wrong. There is no 51 ohms here, or 50 some ohms. I can check that right now. I don't know what the meter was reading, but it read a low resistance. So let's check this right now. I've got a DC meter here. I'll put this so you can see it. And then let's test this. And it's probably going to go way up into the megohm range. So yeah, like I don't know what the meter was reading. I could try it again and I could show you. But here right now we're at 3.5K and climbing. And then it goes open circuit once it hits a certain point. So let me discharge this. Let's try it on my meter again. Okay. So it says DC resistance right now. If I connect this up, it shows 75 ohms about. Our out is at 100 ohms. Let me see if I can change that range. Go here. So that's what the cap's reading, 8600 microfarads. But I'm at 1 kilohertz. Let's turn this down to 120 hertz. Doesn't make much difference. 8500 microfarads. DC resistance though, this should show me actually true DC resistance, but it's not. It's showing me some phantom number. So yeah, I think it was Eric that said it in the comments, and I agree with him. There's no way that these are 50 ohms each, even though my meter is showing some kind of weird resistance. I don't know what it's measuring, but these caps definitely are tired and they need to go anyway, but I just wanted to clear that up. So this one's done. The other two that I had on the bench when I made the channel update video, they're going to come up, but they're going to have to wait a while because I got some other interesting stuff coming up. I have a few things on the brew here, and I got a NAD amplifier, and I have another HK receiver coming up. So I'm going to try and get to those before summer's over, and hopefully we can get it all done. But again, thanks for watching. This was a fun one to work on, even though it was a lot of work. So I'm going to really enjoy listening to this one right now. So take care, and we'll see you on the next one.